Hello friends, welcome back to my YouTube channel. In part number 13, I will continue my discussion on molecular diffusion. In part number 12, I have discussed how you can estimate or you can calculate diffusion coefficients for gases by using equations that have been proposed in the literature. So in this video lecture, I will use those equations for solving numericals where we will be calculating diffusion coefficients in gases. So I will be discussing three numericals which will tell you how you can use the equations that are proposed in the literature to find diffusion coefficients for gases. So let us begin the discussion. Numerical number 1, the statement for this numerical, let me tell you. Find the diffusion coefficient of acetone vapors in air at 27 degrees Celsius and 1 atmosphere using Fuller's et al. Method. So we are supposed to find out diffusion coefficient of acetone in air at a temperature of 27 degrees Celsius and a pressure of 1 atmosphere using Fuller's et al. Method. So various atomic volumes are given to us. For carbon, the atomic volume is 16.5. For hydrogen, it is 1.98. And for oxygen, it is 5.48. The sum of the structural volumes for air, it is directly given to us. It is 20.1. For acetone, we need to find out the sum of structural volumes. But for air, it is directly given to us. It is 20.1. So first of all, we will note the given things. Acetone vapor, let us denote it by capital E. And air, we are going to denote by capital B. The temperature is given to us. It is 27 degrees Celsius. That is 27 plus 273.15, which is 300.15 Kelvin. We need to use temperature in Kelvin. Then pressure is given to us. Pressure is 1 atmosphere. And with Fuller et al. Method, it has to be used in atmosphere. So P is 1 atmosphere and it has to be used in atmosphere. So there is no need of any conversion. Then atomic volumes are given to us. For carbon, let us denote it as Vc, it is 16.5. For hydrogen, it is let us denote it as Vh, it is 1.98. And for oxygen, VO, for oxygen atom, it is 5.48. Then sum of structural volumes for B is given to us. That is summation of Vb is directly given to us. It is 20.1. What is the objective? The objective is to find DAB, that is diffusion coefficient of acetone vapors in air by using Fuller's method. Fuller method. So let us solve this. So we need molecular weights of A and B. So first we will get those molecular weights. The molecular formula for A, that is acetone, it is C3H6O. The molecular formula for A, which is acetone, it is C3H6O. Therefore, molecular weight for A will be equal to 3 atoms of carbon into its atomic weight plus 6 atoms of hydrogen into its atomic weight plus 1 atom of oxygen into its atomic weight. So that gives us molecular weight of acetone as 58. That is Ma is 58. And we know molecular weight of air, that is molecular weight of B, is 29. We are going to use that. Then let us find out sum of structural volume increments for acetone. So for A, in acetone there are 3 carbon atoms, 6 hydrogen atoms and 1 oxygen atom. So sum of structural volumes, it will be 3 into atomic volume for carbon, because there are 3 carbon atoms, plus 6 into atomic volume of hydrogen. There are 6 atoms of hydrogen, and plus 1 into atomic volume for oxygen. There is 1 atom of oxygen. So Vc is 16.5, Vh is 1.98, Vo is 5.48. So if you use these values in this equation, we are going to get summation of Va is equal to 3 into 16.5 plus 6 into 1.98 plus 1 into 5.48. That gives us summation Va as 66.86. Then for B, it is directly given to us, summation of Vb, it is directly given, it is 20.1. Let us move ahead. Now the applicable equation, the equation proposed by Fuller et al. Is this: dAb is equal to 1 into 10 to the power minus 7 into t raised to 1.75 into under root of 1 upon ma plus 1 upon mb divided by P into summation of Va raised to 1 by 3 plus summation of Vb raised to 1 by 3 and square of the sum. So Ma is 58, Mb is 29, summation of Va is 66.86. We found out summation of Vb is 20.1, temperature is 300.15 Kelvin, pressure is 1 atmosphere. We have to use it in atmosphere. So if you use all these values, what do you get? dAb is equal to 1 into 10 to the power minus 7 into 300.15 raised to 1.7 into under root of 1 by 58 plus 1 by 29. It is under root of 1 upon ma plus 1 upon mb. So that is under root of 1 upon 58 plus 1 upon 29. This whole thing divided by pressure is 1 atmosphere into summation of Va is 66.86 raised to 1 by 3 plus summation of Vb is 29 raised to 1 by 3 and square of this sum. So that is dAb is equal to 1 into 10 to the power minus 7. This is this term 300.15 raised to 1.75 is 2164 4.23, 2164 into 1 upon 58 is 0.17, 1 upon 29 is 0.034. Therefore, you have under root of 0.017 plus 0.034 divided by 1. 66.86 raised to 1 by 3 is 4.06. 29 raised to 1 by 3 is 2.72, square of this. So that is dAb is equal to 1 into 10 to the power minus 7 into 21644.23 into the summation of this is under root of 0.05 and divided by this sum 4.06 plus 2.72 is 6.78, square of that. So that will give us dAb. So dAb will be equal to 1 into 10 to the power 1.07 into 10 to the power minus 5 meter square per second. So if you solve the right hand side of this equation, you are going to get dAb as 1.07 into 10 to the power minus 5 meter square per second. So in this way, you have to use the equation that is proposed by Fuller and others for finding out diffusion coefficients in gases. So here the main thing is you should know how to get summation of Va and summation of Vb. The atomic volumes will be provided to you, and depending on number of atoms that are present in the molecule, you have to find out summation Va and summation Vb. In this case, B, the other component is air, and for air summation of Vb is directly given to us. So that's why we have used it. We have used it as it is given, but we have found out summation of Va. So with this, we complete our discussion for numerical number 1. Next, we are going to discuss numerical number 2. Now let us look at numerical number 2 statement. So here, N-butanol is diffusing through air at 1 standard atmosphere. Using Fuller et al. Method, estimate the diffusivity for the following cases. For 0 degrees Celsius, for 25.9 degrees Celsius, for 0 degrees Celsius and 2 atmosphere. Then various atomic volumes, they are given to us. For carbon, it is 16.5. We have used it in the previous example. Then for hydrogen, it is 1.98. And for oxygen, it is 5.48. So, and then the sum of structural volume for air, it is directly given to us. It is 20.1. So, in this case, there is diffusion of N-butanol through air. And it is happening at 1 standard atmosphere. And then by using Fuller-Etel method, we have to find out the diffusivity for various cases. For 0 degrees Celsius and 1 atmosphere, for 25.9 degrees Celsius and 1 atmosphere, and in the third case, we have to get it at 0 degrees Celsius and 2 atmosphere pressure. So let us move ahead. Okay, so first of all, we will list what is given to us. We have N-butanol, we are going to denote that by A, and air, we are going to denote that by B. Atomic volumes are given. For carbon, it is 16.5, Vc is equal to 16.5. For hydrogen, Vh is equal to 1.98. For oxygen, Vo is equal to 5.48. And sum of structural volume for B, that is air, it is directly given to us. Summation of Vb is 20.1. And then what is the objective? The objective is to find DAB, that is diffusion coefficient, by using Fuller's method at 0 degrees Celsius and 1 atmosphere, at 25.9 degrees Celsius and 1 atmosphere, and then at 0 degrees Celsius and 2 atmosphere. Now let us solve this numerical. So first we will need molecular weights of A and B. So molecular formula for E, it is 6C4H10O. So therefore molecular weight of E, that is Ma, will be equal to 4 carbon atoms into atomic weight of carbon plus 10 hydrogen atoms into atomic weight of hydrogen plus 1 oxygen atom into atomic weight of oxygen. That gives us Ma as 74. Then molecular weight of B, it is known to us, it is 29. So Mb is 29. It is known. Then sum of structural volumes, volume increments for A we will calculate as we did it in the previous example, numerical number 1. So in this case, there are 4 carbon atoms, 10 hydrogen atoms and 1 oxygen atom. So summation of Va will be equal to 4 into Vc plus 10 into Vh plus 1 into Vo. Vc is given to us, it is 16.58. Vh is 1.98. Vo is 5.48. So if you use these values, we will get summation Va is equal to 4 into 16.5 plus 10 into 1.98 plus 1 into 5.48. That gives us Va, summation Va as 91.28. And then for B, the sum of structural volumes, it is directly given to us. Summation of Vb is 20.1 and we are going to use that. Let us move ahead. First, let us find out DAB at 0 degrees Celsius and 1 atmosphere. So T is 0 degrees Celsius, that is 0 plus 273.15, which is 273.15 Kelvin. Then pressure is 1 atmosphere and we have to use it in atmosphere. The applicable equation proposed by Fuller Etel, the equation is DAB is equal to 1 into 10 to the power minus 7 T raised to 1.7 into under root of 1 upon Ma plus 1 upon B divided by P into summation of Va raised to 1 by 3 plus summation of Vb raised to 1 by 3 and square of this sum. So Ma is 74, we have found out. Mb is 29, summation of Va is 91.28, summation Vb is 20.1. So we just have to then temperature and pressure. We have temperature is 273.15, pressure is 1 atmosphere. Therefore, DAB will be equal to 1 into 10 to the power minus 7 into 273.15 raised to 1.75 into under root of 1 divided by 74 plus 1 divided by 29 divided by 1 into 91.28 raised to 1 by 3 plus 29 raised to 1 by 3 square of this. That gives us DAB as 1 into 10 to the power minus 7. This 273.15 raised to 1.75 is 18352.79 into under root of 1 upon 74 is 0.014, 1 upon 289 is 0.034, divided by 1 into 19.28 raised to 1 by 3 is 4.50, 29 raised to 1 by 3 is 2.72. So DAB is 1 into 10 to the power minus 7 into 18352.79 into under root of 0.05 divided by 7.22 square. That gives us DAB as 7.22 into 10 to the power minus 6 meter square per second. Therefore, diffusion coefficient of N-butanol in air at 0 degrees Celsius and 1 atmosphere, it is 7.22 into 10 to the power minus 6 meter square per second. Now let us get DAB at other conditions. So now let us get DAB at 25.9 degrees Celsius and 1 atmosphere. So T is 25.9 degrees Celsius, which is 25.9 plus 273.15, that is 299.05 Kelvin. Pressure is 1 atmosphere and you have to use it in atmosphere. The applicable equation, Fuller's method, DAB is equal to 1 into 10 to the power minus 7 T raised to 1.75 into under root of 1 upon MA plus 1 upon MB divided by P into summation VA raised to 1 by 3 plus summation VB raised to 1 by 3 and square of this sum. Now one thing is, what you can do, you can use this equation directly by putting the values that are known to you. The other way is, from this equation, the DAB, diffusion coefficient, is directly proportional to T raised to 1.75 and it is inversely proportional to P. All other terms are constant. So we have this relationship. DAB is directly proportional to T raised to 1.75 and it is inversely proportional to P. Now we will understand how to use this relationship if you know diffusion coefficient at one temperature and pressure. And then how can you find diffusion coefficient at some other temperature and pressure? So sometimes they will give you diffusion coefficient at one temperature and pressure and they will ask you to find diffusion coefficient at some other temperature and pressure. So in that case, you can use this relationship. Now for time being, if I introduce a proportionality constant, DAB will be equal to K into T raised to 1.75 divided by P. Now, if I call these conditions, this temperature, if I call temperature at this condition as T1 and pressure as P1, so at T1 is equal to 273.15, the previous condition where we had evaluated a diffusion coefficient at T1 is equal to 273.15. So I will denote that by subscript A. So at T1 is equal to 273.15 Kelvin and P1 is equal to 1 atmosphere. DAB1 will be equal to K into T1 raised to 1.75 divided by P1. We had calculated it previously. So DAB1 was 7.22 into 10 to the power minus 6 meters square per second. So if I use it, this will be 7.22 into 10 to the power minus 6, that is equal to K into 273.15 raised to 1.75 divided by 1, that is 7.22 into 10 to the power minus 6 is equal to K into 273.15 raised to 1.75, and I am calling this as equation number 1. So let us move ahead. Then I am denoting condition 2 where temperature is 299.05 Kelvin. So at T2 is equal to 299.05 Kelvin and P2 again is 1 atmosphere. So the equation will be DAB2 is equal to K into T2 raised to 1.75 divided by P2. Now in this case T2 and P2 they are known to us, but DAB2 is not known, that is the objective. So therefore DAB2 will be equal to K into 299.05 raised to 1.75 because T2 is 299.05 raised to 1.75 divided by P2 is again 1. So that gives us DAB2 as K into 299.05 raised to 1.75. And now I am calling this as equation number 2. Let us move on. So we got two equations. One is 7.22 into 10 to the power minus 6, that is equal to k into 273.15 raised to 1.75. That was equation number 1. And the other equation was dAB2 is equal to k into 299.05 raised to 1.75. That was equation 2. Now what I will do, I will divide equation 1 by equation 2. That is, left hand side will be left hand side of 1 will be divided with left hand side of 2. Right hand side of 1 will be divided with right hand side of 2. So that will be 7.22 into 10 to the power minus 6 divided by dAB2. That is equal to k into 273.15 raised to 1.75 divided by k into 299.05 raised to 1.75. Now k will get cancelled. So it will be 7.22 into 10 to the power minus 6 divided by dAB2. That is equal to 18352.79, because 273.15 raised to 1.75 is 18352.79. Then 299.05 raised to 1.75 is 21505.60. So that gives us dAB2 as 7.22 into 10 to the power minus 6 into 21505.60 divided by 18352.79. That gives us dAB2 as 0.17. This product is 0.17 divided by 18352.79. That is, dAB2 comes out to be 9.04 into 10 to the power minus 6 meters square per second. Therefore, diffusion coefficient at a temperature of 25.9 degrees Celsius and 1 atmosphere, it is 9.04 into 10 to the power minus 6 meters square per second. Let us move on. Okay, now let us get DAB at 0 degrees Celsius and 2 atmosphere. So in this case, temperature is 0 degrees Celsius, that is 0 plus 273.15. That is 273.15 Kelvin. P is 2 atmosphere. We have to use it in atmosphere. At T1, the first condition, where we calculated at 273.15 and 1 atmosphere. We are going to consider that as condition 1. So at T1 is equal to 273.15 Kelvin and P1 is equal to 1 atmosphere. We have equation 1. We had got this equation 7.22 into 10 to the power minus 6, that is equal to k into 2 raised to 273.15 raised to 1.75. Now the condition 2 is this condition at T2 is equal to 273.15 Kelvin and P2 is equal to 2 atmosphere. dAB2 will be equal to k into T2 raised to 1.75 divided by P2. dAB2 we have to get, and it will be equal to k into 273.15 raised to 1.75 divided by 2. You please note that for every part, or for estimation at 0 degrees Celsius and 2 atmosphere, I have considered condition 1 as DAB that is known to me, and condition 2 as where DAB has to be found out. So in previous part also, we had considered T1, P1 and then condition 2 as T2, P2. T1, P1, at T1, P1, DAB1 was known, and at T2, P2, we had to get DAB. So in this case, T1, P1, at T1, P1, DAB is known, and we are going to get at T2, P2. Okay, so DAB2 in this case will be 0.5 into k into 273.15 raised to 1.75. I am calling this as equation number 3. And now we will divide equation 1 by equation 3, same thing. So it will be 7.22 into 10 to the power minus 6 divided by dAB2, that is equal to k into 273.15 raised to 1.75 divided by 0.5 into k into 273.15 raised to 1.75. So we will be left with 7.22 into 10 to the power minus 6 divided by dAB2 is equal to 1 upon 0.5. Rest everything will get cancelled. That is, dAB2 will be equal to 0.5 into 7.22 into 10 to the power minus 6. That is dAB2. It will be 3.86 into 10 to the power minus 6 meters square per second. So in this way, we keep diffusion coefficient at 0 degrees Celsius and 2 atmosphere. So when diffusion coefficient at one temperature and pressure is known to us, we can get diffusion coefficient at some other temperature and pressure by knowing the relationship between DAB, T and E. So according to Fuller's method, DAB is directly proportional to T raised to 1.75 and it is inversely proportional to pressure. So I hope you have understood how to use the relationship. Let us move on. Okay, so we completed solution for numerical number 2. Now let us go for numerical number 3. Numerical number 3 statement. Calculate the diffusion coefficient of dry hydrogen in air at 20 degrees Celsius and 1 atmosphere using Gilliland's equation. The molecular volumes of air and hydrogen are 29.9 centimeter cube per gram mole and 14.3 centimeter cube per gram mole respectively. So now we have to find out the diffusion coefficient of dry hydrogen in air at a temperature of 20 degrees Celsius and a pressure of 1 atmosphere. But in this case, we have to use Gilliland's equation for getting the diffusion coefficient. What is given to us? The molecular volumes of air and hydrogen, they are given to us. For air, it is 29.9 centimeter cube per gram mole, and for hydrogen, it is 14.3 centimeter cube per gram mole, respectively. So let us solve this. So first of all, we will know what is given to us. Dry hydrogen, we are going to denote that by E, and air, we are going to denote by B. So temperature is given to us. It is 20 degrees Celsius. That is 20 plus 273.15, which is 293.15 Kelvin. Then pressure is given. Pressure is 1 atmosphere. We have to use it in atmosphere. Then molecular volumes are given to us. V is 14.3 centimeter cube per gram mole for hydrogen. For hydrogen, it is 14.3 centimeter cube per gram mole. And for air, it is Vb is equal to 29.9 centimeter cube per gram mole. What is the objective? The objective is to find the diffusion coefficient, that is dA. And for that, we have to use Gilliland's equation. So let us solve it. So first we will need molecular weights. So we will first find them. The molecular formula for E is H2. Therefore, molecular weight of E will be equal to, that is Ma will be equal to 2 atoms of hydrogen, and atomic weight of hydrogen is 1. So Ma is 2. Then molecular weight of B, which is air, it is 29. Mb is 29. Which is the applicable equation? Gilliland's equation. The equation is dAb is equal to 0.0043 T raised to 1.5 into under root of 1 upon Ma plus 1 upon Mb divided by P into Va raised to 1 by 3 plus Vb raised to 1 by 3 and square of this sum. Now let us use the values that are known to us. Temperature is 293.15 Kelvin. Pressure is 1 atmosphere. Va is 14.3 centimeter cube per gram mole. Vb is 29.9 centimeter cube per gram mole. So when we use the values, dAb will be equal to 0.0043 into 293.15 raised to 1.5 into under root of 1 by 2 plus 1.1 divided by 29. I have used Ma is 2, Mb is 29 divided by 1 into 14.3. Va is 14.3 raised to 1 by 3 plus Vb is 29.9 raised to 1 by 3 and square of this sum. So that gives us dAb as 0.0043 into this term is 5019.20 and this term is under root of 0.53. This term, sum is 5.53, so it will be 5.53 square. So that gives us dAb as 0.52 centimeters square per second, because we have used the molecular volume in centimeter cube per gram mole. So that's why we are getting DAB in centimeter square per second, and you can easily convert it to meter square per second. So for that, I have to multiply with 10 to the power minus 4. So DAB will be equal to 0.52 into 10 to the power minus 4 meter square per second. Or it is 5.2 into 10 to the power minus 5. It is 5.2 into 10 to the power minus 5 meter square per second. So in this way, you can find out diffusion coefficients by using Gilliland's equation. So with this, I will end my discussion for this video lecture. So here we have learned how to use various equations that are proposed in the literature to find the diffusion coefficient. We have learned how to use the Fuller's method. Then we have learned how to use the Gilliland's equation. So I hope you have understood the steps that I have used in solving these three numericals. So if you have any doubts, you please mention them in the comment section. For now, let me end this discussion. In my next video lecture, I will discuss one more numerical that is based on diffusion through gases, or that is based on finding diffusion coefficients for gases. So for now, let us end the discussion. So thanks for watching this video lecture. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. So for now, have a nice day. Hope to see you soon in my next video lecture. Have a nice day. Bye bye.